Video we're going to take a look at the Crooked Crockford challenge on HackTheBox. So it's a medium challenge in the miscellaneous category, and the description says some bits are missing. So let's download the files and see what we have. We've got a file called crookedcrockford.txt. We'll copy it over to our local directory, and let's go and see what we have here. We can print it out first of all. We can see here we've got a string consisting of R's and commas. So it's that these are binary values, so these could be zeros and ones, or A's and B's, or R's and commas, whatever you want to, however you want to represent them. But essentially they're binary values. Let's open this up and let's put these into a separate file. I'm going to assume that, seeing as the R's are ones and the commas are zeros, but we might need to swap that round at some point. Let's swap R for 1, and then let's swap comma for 0. Okay, now we've got a binary string that we can go and take a look at and see if we can decode it. So we'll open up CyberChef first of all and throw this binary string in there. Try to convert from binary, and no delimiter. Okay, not much there. We have this byte with byte length here. This is at least showing some plain text. Let's try and run magic on it after that, just to see if it's able to decode it. No. Alright, I was thinking maybe it would try. It did try Base64 and Base58, but didn't come back with anything. Okay. Let's have a look here. We also had another possibility we dealt with before was, let's do cipher decode. The bacon cipher, let's pause this. The bacon cipher dealt with, it takes 2 characters. In this case, I and U, I guess. But wait, no, this is just, okay, that's the alphabet. We put that, so this is 0 and 1 here because we've obviously put zeros and ones in here. But it could take A and B, or A and N. I think, what was the, it was A and N in the challenge that we dealt with this in. But anyway, enough rambling. If we try to do the bacon cipher decode here, no matter what parameters we're giving it there, it doesn't seem to translate to anything meaningful. So let's turn that back on from binary, and we can, let's, what was the challenge name? The challenge name is Crooked Crockford. Let's search here Crooked. Let's search Crockford. Nothing. Let's go to decode.fr and try the same thing. Search for Crooked. Nothing. Search for Crockford, and we find a Base32 Crockford algorithm created by Douglas Crockford, improving use by humans. And we can see that it takes in a parameter here, so we could pass it in hello, and it will give a Base32 Crockford result. So if we take that and not that, if we take this and then decrypt, we get hello. We can output the results in different formats here, but to decode we have to pass in the plain text. And if we look at how this works here, it's saying that each block is of 5 bits is encoded using the following alphabet. Okay, so, and then is decoded in the same way. So if you were to take our example, let's do, we can if we want to try to split this up into blocks of 5, we can say \d5, make sure the regex thing is enabled there, \d5, and then replace this with $1 and a space, and it will insert a space into all of those, and then we can have a look and see. Notice that the description said some bits are missing, and we're missing some bits at the end here. We're missing 2 bits. If we look here, 1000 equals G. This doesn't equal G here. I thought maybe that would be the case. Or the encoded version. Sorry, what was the this is 10000 is C. 1000. No, it's G both ways. Okay. So C would be. Oops. I accidentally inserted a dot somehow there. Okay. Okay. Let's try and pass this value into Crockford, because it looks a lot like the values that we're dealing with there. And if we try to decode that, it looks like we have our flag. Verify that. And flags accepted. Okay. So let's go back there actually. If we output that to binary, decrypt, that's not what we have here. 01100. Okay, because these are 8-bit values, I guess. Alright, I'm a little confused as to the encoding there. Base is encoded in ASCII 8 bits. Okay. The cutout gives 3 blocks. Ah, okay. So it's the 3 bits that are appended to the end of that. Is that what they're saying? So let's go back there. 010. So it would be 01100. That's not what we have either. Alright, I'm not too sure. I'm doing something wrong there, but we've got our flag. Yeah, if you know what I did wrong, you can let me know in the description below. And I hope you've enjoyed this video. Give it a like, subscribe, and all that. Thanks.